Good evening friends. Today I will take the class of brake. This is a new chapter and this is very important one. So brake. Today the new chapter is brake. So this is very important one. Gate point of view. And before starting this, first of all, I will give you the introduction and complete theoretical detail of this chapter before going to the equations, types of brakes, and initially I will start from the definition that what is brake? What is brake? ब्रेक क्या है? जैसे आपने देखा होगा, mostly you know because everybody is having the vehicle and they know it, that brake is a device to provide the frictional resistance. जब हम ब्रेक लगाते हैं, सपोज करो एक व्हीकल जो है आप ड्राइव कर रहे हैं तो ब्रेक लगाते हैं, उससे क्या होता है? या तो स्पीड उसका रिटार्ड होगा, स्पीड कम करने के लिए लगाते हैं. आइदर इफ यू हैव टू स्टॉप द व्हीकल, if you have to stop something moving body, you have to apply the brake. So the function of brake is to either retard the motion of the body or to stop the motion of the body. So this is the function of the brake. So brake definition जो इसकी है, so brake is a device, brake is a device by means of which the frictional resistance frictional resistance means, what is the frictional resistance? That is the artificial. So artificial frictional resistance is applied on the moving. Brake is a device by means of which the frictional resistance is applied on the moving machine member or any moving body to retard or stop its motion. So this is the definition of the brake. You understand that brake is a device by means of which the artificial frictional resistance is applied on the moving machine member or any moving body to retard or stop its motion. तो ब्रेक क्या है? ब्रेक एक डिवाइस है when we are providing the frictional artificial resistance by means of brake to some moving body to stop it or to retard its motion. So this is called the brake. अब जब ब्रेक आप लगाते हैं, so what happens? Due to this, so due to braking or during the process, तो इस प्रोसेस में क्या होगा? ड्यूरिंग दिस प्रोसेस what happens? During this process what happens? The energy is produced, right? During this process what happens? Energy produced, राइट। तो इस प्रोसेस में जब आप ब्रेक लगाएंगे, when you apply the brake, what happens? The energy produced, it is either this energy, it is either kinetic energy or potential energy, that depends upon the motion of the body, or that depends upon the position of the body, right? That depends upon the motion of the body or the position of the body. So this energy is produced, kinetic energy is produced, right? So this kinetic energy means, this kinetic energy, there is a change in kinetic energy there, right? So kinetic energy में क्या होगा? There is a change in kinetic energy, because when a body is moving, it is moving with certain velocity, and when we apply the brake, what happens? Its velocity reduced. When its velocity reduced, what happens? There is a change in energy, there is a change in kinetic energy, and this change in kinetic energy is being absorbed by the brake, right? This change in kinetic energy is being absorbed by the brake. So ये जो एनर्जी ब्रेक अब्जॉर्ब करेगा, सो व्हाट, इसके बाद क्या होगा? नेचुरली इसको हमने डिसिपेट करना है सराउंडिंग एयर में. अगर नहीं करेंगे तो इट विल अफेक्ट द फ्रिक्शन लाइनिंग एंड इट विल डिस्ट्रॉय द सिस्टम. सो फ्रिक्शन लाइनिंग में ये अफेक्ट करेगा, तो इमीडिएटली वी हैव टू डिसिपेट द एनर्जी. तो जो एनर्जी काइनेटिक शेप में, जो पोटेंशियल एनर्जी शेप में जो एब्जॉर्ब करेगी ब्रेक, सो यू कैन से this change in kinetic energy or potential energy क्या करेगा? ये this is absorbed by the brake. So this energy is absorbed by the brake, and then there is a heat transmission. This energy is transformed to heat. There is a heat produced, और ये जो heat है, that should be dissipated in the surrounding air or being absorbed by the cooling water which has been flown through the passage of the drum, right? So this is about the brief description of the brake actually. So what is the function of the brake? So function of the brake क्या है? Brake is a device by means of which the frictional resistance is applied on the moving machine, member, and or any moving body to retard or stop its motion. And when we apply this, during this process, what happens? The energy produced, right? So this energy being absorbed, right? This energy, this is either kinetic energy or the potential energy, right? So this change in kinetic energy or potential energy which is produced being absorbed by the brake, और brake in terms what क्या होगा? ये जो energy absorb करेगा, heat produce होगी, and heat that should be dissipated to the surrounding air or being absorbed by the water which is being flown through the drum, passes of the drum. ठीक, right? So this is, I have given you a brief description, but now there are the अब ये जो एनर्जी एब्जॉर्ब करेगा, दिस एनर्जी एब्जॉर्ब्ड बाय द ब्रेक डिपेंड्स अपॉन द मोशन ऑफ द बॉडी, राइट? तो ये किसके ऊपर डिपेंड करेगा? डिपेंड्स अपॉन the motion of, depends upon the motion of the body, right? क्योंकि जो बॉडी का मोशन होगा उसके ऊपर ये डिपेंड करेगा कि इस बॉडी में कितना एनर्जी जो है जब ब्रेक अप्लाई करेंगे तो कितना चेंज इन एनर्जी प्रोड्यूस होगा जो कि ब्रेक जो है उसको एब्जॉर्ब होगा, राइट। सो देयर आर सर्टेन टाइप्स ऑफ मोशन, राइट। So you can say the type of motion of the moving body depends upon the motion of the body. So first you can say pure translation motion. When the body is running, when the body is moving in a straight line, or when the body is moving linearly, then this is called the pure translation motion. Or second one is your rotational motion, and third one is both of these. तीनों में ये हो सकता है, राइट। Now I will take one by one. Okay, how much energy we will get in case of pure translation motion, and what type of energy we will get here, what type of energy we will get in the rotational, what type of energy we will get in the rotational motion. So first I will take this translation motion. So what is translation motion? Translation motion. Translation motion. Consider a body. Suppose आप एक बॉडी को कंसिडर करें. Consider a moving body of mass m with velocity v1 meter पर सेकेंड। तो एक बॉडी को मूव करें, कंसिडर करें जो बॉडी मूव कर रही है किस वेलोसिटी से, v1 मीटर पर सेकेंड v1 मीटर पर सेकेंड। मास उसका बॉडी का क्या है, m है, एंड ये मूव कर रही है इससे। नाउ यू विल अप्लाई द ब्रेक. सपोज इफ यू अप्लाई द ब्रेक, व्हाट हैपन्स, इट्स स्पीड, पहले जो स्पीड था इसका b1 मीटर पर सेकेंड था, इट्स स्पीड रिड्यूसेस फ्रॉम b1 meter per seconds to say b2 meter per second square. So after applying the brake, you can say, so after applying the brake, the velocity reduces to v2 मीटर पर सेकेंड्स. समझ आया? जब आप ब्रेक लगाएंगे तो वेलोसिटी जो है v1 मीटर पर सेकेंड से v2 मीटर पर सेकेंड में रिड्यूस हो जाएगी, राइट? सो इस केस में क्या होगा? सो व्हाट हैपेंस इन दिस केस, देन नेचुरली देयर इज ए चेंज इन काइनेटिक एनर्जी. सो पहले काइनेटिक एनर्जी था आपका 1/2 mv1 स्क्वायर. जब हमने ब्रेक लगाया काइनेटिक एनर्जी इसका हो गया 1/2 mv2 स्क्वायर. सो व्हेन द वेलोसिटी रिड्यूसेस, सो इट मींस इट्स काइनेटिक एनर्जी चेंजेस फ्रॉम 1/2 mv1 स्क्वायर टू 1/2 mv2 स्क्वायर. सो देयर इज ए चेंज इन वेलोसिटी. So in this case you can say change in kinetic energy. Change in kinetic energy change in kinetic energy, this is equal to 1 by 2 mb1 square minus 1 by 2 mb2 square। ये कंफर्म हो गया पॉइंट आपको। एक बॉडी मूव कर रही है जिसका मास m है, इट्स मूविंग विद b1 मीटर पर सेकेंड स्क्वायर वेलोसिटी से, देन वी पुट द ब्रेक, then we apply the brake on that moving body. What happens? Its velocity reduces from b1 meter per second to b2 meter per second. So in this case there is a change in kinetic energy because the body is moving linearly. Its motion is translation motion. So kinetic energy change आएगा 1 by 2 this, and this is equal to 1 by 2 m v1 square minus b2 square. So this much of the energy, this is the change in energy, this much of the energy, you can say this much of the energy is being absorbed by the brake. This much of the energy is being absorbed by the brake if the body is moving in the translation motion, right? If the body is moving in the translation motion, then this much of the energy is being absorbed by the brake. So if I will say this is simply retarding the speed, means speed is changing from b1 meter per second to b2 meter per second, but still the body is moving. If I say if the body will stop, then what happens? If the body will stop after applying the brake, if the body will stop after applying the brake, then what happens? It's this velocity b2, you can say b2 is 0, right? So b2 is 0. So in this case, your change in kinetic energy, if the body will stop or made to stop, in this case change in kinetic energy is equal to 1 by 2 m v1 square. So this much of the energy, because this is a change in the energy, so this much of the energy is being absorbed by the brake. You understand this? So this is your, when the body is moving in the translation motion, when the body is in the translation motion, then this much of the energy is being absorbed by the brake. So second condition, if I will take, when the body is in the rotational motion, when the body is rotational motion, जब बॉडी रोटेशनल मोशन में होगी उस वक्त कितनी एनर्जी ये एब्जॉर्ब करेगी, दिस वी विल कैलकुलेट आल्सो। अगर हम ब्रेक को अप्लाई करते हैं, एक बॉडी जो है वो रोटेशनल मोशन में अपने एक्सिस के ऊपर रोटेट कर रही है, एंड वी आर पुटिंग द ब्रेक ऑन दैट बॉडी, moving body, we are putting the brake on that moving body which is rotating on its own axis, having the moment of inertia I. So its velocity, its angular velocity, that is reduced. If suppose, if say the body is rotating with the angular velocity omega 1 at its own axis, and now I am putting the brake on that body, what happens? You are, after putting the brake, after applying the brake there, your angular velocity, that will change, that will reduce. So say if before applying the brake, the angular velocity is omega 1, and after applying the brake, the angular velocity is omega 2, then we will calculate the change in kinetic energy here, and that kinetic energy is being absorbed by that, right? So ये कितना आएगा, ये जस्ट हम ले लेते हैं, let omega 1 the angular velocity, the angular velocity of the rotating body at its own axis, at its own axis, so I, you can say I is the moment, I is equal to the moment of inertia, I is equal to the moment of inertia at the axis of rotation, at the axis of rotation, right? ये हो गया फर्स्ट कंडीशन में, एक बॉडी जो है रोटेट कर रही है विद द एंगुलर वेलोसिटी ओमेगा 1 और उसका आई मोमेंट ऑफ इनर्शिया है एक्सिस के ऊपर, उसका एक्सिस का जो मोमेंट ऑफ इनर्शिया है एक्सिस के ऊपर, वो आई इज द मोमेंट ऑफ इनर्शिया. नो व्हाट वी विल डू, वी अप्लाई द ब्रेक हियर. सो व्हेन वी अप्लाई द ब्रेक, when the brake is applied, when the brake is applied, what happens? Its angular velocity, the angular velocity of the rotating body, that reduces omega 1 to, so omega 2 you can say, omega 2 is the angular, omega 2 is the angular velocity, right, of the rotating, angular velocity of the rotating body after the brake, after the brake is applied. So its velocity reduces. So therefore there is a change in kinetic energy. इसमें क्या change in kinetic energy आएगा, right? So the change in kinetic energy, this is equal to 1 by 2 I omega 1 square minus omega 2 square. So this is the change in kinetic energy, 1 by 2 I omega 1 square minus omega 2 square. So this much of the energy, this much of the energy which is the change in kinetic energy after applying the brake, the angular velocity of the rotating body omega 1, that changes from omega 1 to omega 2. So there is a change in kinetic energy, and this change in kinetic energy is being absorbed by the brake, right? You understand? So this much of energy, you can say, this much of energy being absorbed by the brake when the body is in the rotation. When the body is in the rotation, so if we will put the brake, this much of the energy is being absorbed by this. And if the finally we put the brake and your this body will stop, finally if the body will stop, if you put the brake and the body will stop, so in this case what is there, your omega 2 this is equal to 0. So इस case में if the body stop, if the body will stop, आप ब्रेक अप्लाई करते हैं और बॉडी आपका स्टॉप हो जाता है, तो उस केस में क्या होगा, इट मीन्स का फाइनल वेलोसिटी दैट इज 0, ओमेगा 2 दिस इज 0. So in this case change in kinetic energy is how much? So in this case change in kinetic energy this is equal to 1 by 2 I omega 1 square. So this much of the energy is being absorbed by the brake, right? So this is the second one. First, I have given you the description when the body is in translation motion. So how much energy is being absorbed by the brake, and this when the body is in rotation, then how much energy is absorbed by the brake. This is the relation. And the third one, suppose if say this is your E1, this is your E1 and this is your E2. Suppose if I say this is your E1 and this is your E2, and when I am taking the condition of both, means when the body is in circular motion or rotation as well as in translation motion, as in case of the wheel of a car, right, a locomotive driving wheel. So in this case where the both combinations, so in this case how much energy is being absorbed, how much energy is being absorbed by the brake. So this is when you will apply the brake in the case of so in case of third case, you can say in case of third combination, case of combination of both, that is translation and rotational, ट्रांसलेशन एंड रोटेशनल मोशन. तो जब ये कॉम्बिनेशन दोनों का होगा तो इन केस ऑफ ट्रांसलेशन मोशन आई हैव कैलकुलेटेड द वैल्यू ऑफ चेंज इन काइनेटिक एनर्जी. से दिस इज E1, दिस इज आई हैव कैलकुलेटेड 1 by 2 m V1 square minus V2 square. यही था ना. When we apply the brake, if a body is moving with initial velocity v1 meter per second square, and when I will apply the brake, the velocity reduces from v1 to v2, then the change in kinetic energy E1 is equal to this one when the body is in the translation motion. And when the body is in circular motion, this is E2, so this is equal to 1 by 2 I omega 1 square minus omega 2 square. So this is the change in energy, change in kinetic energy in case of rotational motion. You can say this is your translation motion. ये आपका translation motion में था. This is your rotational motion. So then the total energy, if a body is having the combination of both, as I have given you the example of the driving wheel of the locomotive or your driving wheel of your this car. So in this case both the motions are there, and when we apply the brake, the body is made to stop, or body is made to stop in the translatory motion also, and in the rotational motion of the wheel also. So in this case when the motion is same, so this is E1 and E2, so you can say that the total energy is how much, total change in energy is how much. So total change in kinetic energy, this is equal to E1 plus E2, right? So this is E1 plus E2. So this much of energy when you will apply the brake on the moving body, and that moving body is having the both motion as well as the translation motion and the rotational motion, In this case, total kinetic energy, this is equal to E1 plus E2, right? So this you understand. Now, next condition I will take. Next condition I will take. This is all about your kinetic energy which I take. Now, next condition I will take then when the body is having the potential energy. So when the body is having the potential energy, suppose if you say a body, suppose if you say a body of mass m or a object of mass m, a body of mass m being lowered from the height h1 to h2 by the hoists or cranes, ठीक है ना, एलिवेटर्स भी यूज करते हैं, विद ब्रेक, विद द हेल्प ऑफ ब्रेक, ठीक है। तो जब बॉडी को लोअर करेंगे तो ब्रेक की हेल्प से, विद हेल्प ऑफ ब्रेक। तो एक बॉडी है, वो बॉडी हाइट के ऊपर है, तो क्रेन से या एलिवेटर से उस बॉडी को ऊपर से वी आर शिफ्टिंग, ऊपर हाइट h1 से हमें उससे शिफ्ट करना है हाइट h2 के ऊपर, राइट। तो जब बॉडी आपकी हाइट h1 के ऊपर होगी तो डेफिनेटली उस बॉडी में उसकी h1 हाइट के ऊपर उसकी कुछ पोटेंशियल एनर्जी होगी, से पोटेंशियल एनर्जी ऑफ द body at height h1, ठीक है। पोटेंशियल एनर्जी ऑफ द बॉडी एट हाइट h1, दिस इज इक्वल टू m into g into h1, where m is the mass of the body, g is gravity, m into g that is weight into h1, this is the height from the reference line, you can say h1 is the height, mg h1. So this is the potential energy of the body when the body is at the height h1. So now this body is being lowered from this height h1. This body is being lowered from the height h1 to height h2 with the help of cranes, elevators or and by applying the brakes, ठीक है ना। तो जब हम इसको ऊपर से हाइट करेंगे तो इस केस में पोटेंशियल एनर्जी ऑफ द बॉडी एट हाइट h2, पोटेंशियल एनर्जी एट द बॉडी एट हाइट h2 क्या होगा, mg h2, ठीक है। जहां तक समझ आया आपको, mg h2। सो देयरफॉर चेंज इन पोटेंशियल एनर्जी, क्योंकि ये जो चेंज इन पोटेंशियल एनर्जी होगी जो mg h1 है और ये हाइट h2 के ऊपर इसका mg h2 है, ये जो चेंज इन पोटेंशियल एनर्जी होगी, जो आप कह सकते हैं जो बॉडी ने गिवन अप किया है, गिवन अप पोटेंशियल एनर्जी को किया है, बिकॉज इसके ऊपर इसकी एनर्जी ज़्यादा थी, पोटेंशियल एनर्जी ज़्यादा थी, इस पर कम थी। सो बॉडी हैज़ गिवन अप द potential energy during lowering from the height h1 to h2, and that potential energy is being absorbed by the brake, right? You understand okay, how much energy is being absorbed by the brake? The energy which is being given up by the body from height h1 to h2, and that energy is being absorbed by the brake. So you can say change in kinetic energy is how much? Change in kinetic energy. So change in, sorry, not kinetic energy, change in potential energy. Change in potential energy, this is equal to mg h1 minus h2. So this is the potential energy which is given up by the object, which is given up by the body during lowering process from height h1 to h2, and this much of energy is being absorbed by the brake, this much of energy is being absorbed by the brake. समझ आया? सेकंड केस में हम ले सकते हैं, ये तो होगा हाइट के केस में. अगर सेकंड केस में लें कि B1 and B2 आर द वेलोसिटी ऑफ द बॉडी बिफोर एंड आफ्टर अप्लाइंग द ब्रेक. ठीक है, अगर B1 and B2 बॉडी की वेलोसिटी है ऊपर से लोअर करने में, नीचे पहले B1 वेलोसिटी थी, B1 and B2 आर द वेलोसिटी बिफोर एंड आफ्टर application of the brake. So in this case change in potential energy, this is equal to mg, mean velocity क्या होगा, B1 plus B2 by 2 into t, right? mg into B1 plus B2 by 2 into t, where t is the time taken to apply the brake. So where V1 and B1 plus B2 by 2y is the mean velocity, right? So this is the change in potential energy in the case when the body is being lowered. B1 its initial velocity, you can say, when the brake is not applied, and B2 is the final velocity after the application of the brake. So in this case the change in potential energy, this is equal to m into g, B1 plus B2 by 2 into t, and you can say this mean velocity. Therefore V is equal to V1 plus V2 by 2. This is your mean velocity, this is your mean velocity. So hence we can write it like this. So this is equal to m into g into v into t, right? So this is the potential energy. काइनेटिक एनर्जी में मैंने आपको बताया कि काइनेटिक एनर्जी के केस में कितना, जब बॉडी जो है लीनियर मोशन में होगी, ट्रांसलेशन मोशन में होगी, रोटेशनल मोशन में होगी, उस वक्त ब्रेक की अगर आप अप्लाई करते हैं कितनी एनर्जी एब्जॉर्ब करेगा. और अगर बॉडी जो है आपकी पोटेंशियल एनर्जी है, अगर बॉडी आपकी किसी हाइट के ऊपर है, उस हाइट से बॉडी को आप लोअर करते हैं, तो देयर आर द टू रिलेशंस. व्हेन वी आर कंसीडरिंग द हाइट, देन द change in potential energy is this much, and this much is energy absorbed by the brake. And if we will take consideration of the velocities, so in case of velocity, then the change in potential energy is mgv into t. So this is your this potential energy. Now we will come to the own topic. Basically this is the energy. Basically now when we are applying the brake on the rotating drum in case of shoe brake, right? So उस वक्त जो एनर्जी होगा, कितना एनर्जी प्रोड्यूस होगा, राइट? सपोज मैं कहता हूं कि ये आपका दिस इज योर ड्रम, राइट? This is your drum, and this is your shoe. This is your drum and this is your shoe. Suppose ये आपका shoe है, right? So drum is rotating. If I say drum is rotating clockwise, ड्रम आपका क्लॉकवाइज जो है रोटेट कर रहा है. तो जब आपका ड्रम क्लॉकवाइज रोटेट करेगा तो ब्रेक, इसमें हम शू को प्रेस करते हैं, लीवर जो है वो शू को प्रेस करेगा. मैंने भी पूरी फुल डायग्राम नहीं बनाया है, जस्ट आई वांट टू गिव यू द आइडिया ऑफ दिस योर द फ्रिक्शनल रेजिस्टेंस, दैट हाउ मच एनर्जी इज बीइंग अब्जॉर्ब्ड व्हेन इट इज मेड टू स्टॉप, व्हेन द ड्रम इज बीइंग मेड टू स्टॉप, at that case how much energy is being stopped, because I am just taking the different type of the energy absorption by the brakes. So simply I am just giving you the idea. So when the drum is rotating clockwise, what happens? Your this frictional resistance force जो आपकी ड्रम के ऊपर है, this is your Ft, this is moving your anti clockwise direction. So anti clockwise direction ये move करेगा, this is called the braking frictional force also, braking force also कह सकते हैं, frictional force आपको कह सकते हैं, ठीक है। तो जब इसको प्रेस करेगा तो क्या होगा? दिस इज रोटेटिंग इन द क्लॉकवाइज डायरेक्शन एंड द शू इज स्टैटिक, एंड when it is pressed with the rotating drum, what happened? There is a relative motion between the shoe and the rotating drum, and that rotating motion will create the frictional force or the braking force, which is perpendicular to its normal force and tangential to the force of the drum, and this is in the opposite direction. If the drum is rotating clockwise, the frictional force will be in the anti-clockwise direction like this, so that this frictional force will made to stop the rotating drum. You understand? So this is the अब ये भी मैं आपको एक्सप्लेन कंप्लीटली करूंगा जब आई विल टेक द डिफरेंट टाइप ऑफ ब्रेक्स। ये मैं सिर्फ अभी ओनली दिस फैक्टर आई वांट टू चूज हियर, ये फ्रिक्शनल रेजिस्टेंस जो है आपका टेंजेंशियल फ्रिक्शनल फोर्स है, अगर जब ये लगती है और रोटेटिंग ड्रम है, उस केस में क्योंकि मैं अभी एनर्जी एब्जॉर्ब के ऊपर कि ब्रेक कितना डिफरेंट पैरामीटर्स के ऊपर, डिफरेंट मोशंस के ऊपर किस हिसाब से कितनी क्वांटिटी में ब्रेक जो है एनर्जी एब्जॉर्ब करती है, तो मेरा जो अभी जो बताने का मतलब है, माई ओनली टू शो दिस। सो इन दिस केस ये आपको इसका समझ आ गया, दिस इज द फ्रिक्शनल रेजिस्टेंस। सपोज इफ आई से Ft is the braking force or tangential frictional force acting opposite to the rotation of drum tangentially at the contact surface, contact surface कौन सा? between the shoe and drum, between the shoe and drum। समझ आया? Ft क्या है? टेंजेंशियल फोर्स है, जब ब्रेकिंग टेंजेंशियल फ्रिक्शनल फोर्स है, जब ब्रेकिंग फोर्स है, जिसका काम है इसके मोशन को ये जो आपका क्लॉकवाइज और एंटी क्लॉकवाइज, इफ आई विल से आई विल टेक एंटी क्लॉकवाइज, then its direction of the frictional force toward this clockwise direction, so that it has to be stopped. So Ft is the braking force of the tangential friction force acting opposite to the rotation of the drum, and ये कहाँ पे एक्ट करती है? जो टेंजेंशियली एक्ट करती है, जो कंटेक्ट एरिया आपका शू का और जो ड्रम का जो कंटेक्ट एरिया होगा, इससे ये ऊपर टेंजेंशियली ड्रम के ऊपर ये एक्ट करेगी इस डायरेक्शन में, ठीक है। लेट आई से D is the diameter, D is the diameter of the rotating drum, right? N1 N1 speed of the drum, N1 speed of the drum before applying the brake, and so on. N2 speed of the drum after the brake applied. If I say N is the mean speed, तो N क्या आएगा? N1 plus N2 Y2, right? N is equal to N1 अब वर्क डन क्या करेगा ये, क्योंकि जब फ्रिक्शनल फोर्स जो है रोटेटिंग ड्रम को इसको इसने स्टॉप करना है, तो नेचुरली ये जहां पे वर्क डन होगा फ्रिक्शनल फोर्स इट ही है वर्क डन, इसको वर्क डन करना पड़ेगा. सो वर्क डन बाय द फ्रिक्शनल फोर्स Ft कितना होगा? This is equal to W Ft into pi into D into N into T. समझ आया जी? सो वर्क डन बाय द फ्रिक्शनल फोर्स कितना? W is equal to Ft into pi into D into N. Pi into D, this is the circumference of this drum, which is the rotating drum. So N is the number of the revolutions, and T is the time taken to apply the brake. So in time T, how much work is being done by this frictional force? So this is equal to W is equal to Ft into pi into D into N into T. So this work done by the frictional force, you can say energy absorbed by the brake. ये समझ आया आपको? भाई जितना ये वर्क डन करेगा इसको रोकने के लिए, इसको स्टॉप करने के लिए रोटेटिंग ड्रम को, इसने वर्क डन किया ये, तो नेचुरली ये एनर्जी जो है, ये एनर्जी यू कैन से एनर्जी इज इक्वल टू Ft into pi into D into N into T. This is joule per second or watt. So this much of energy is being absorbed by the brake. This much of energy is being absorbed by the brake. So this much of energy being absorbed by the brake. तो इस जहां से you can calculate the value of Ft also. If some numericals energy is given to you, somewhere energy is given to you and the other parameter, and you want to calculate the value of Ft, so you can say Ft. So Ft is equal to how much? Ft is equal to how much? This is equal to E upon pi into D into N into T. So this is the value of the frictional force or the braking force in term of energy, right? Ft is equal to E upon pi into D into N into T. Now next is, this is frictional force था, तो ब्रेकिंग टॉर्क इसमें कितना होगा? ये फ्रिक्शनल फोर्स अप्लाई किया है, तो सपोज इफ इट्स इज द रेडियस इज आर एंड डायमीटर आई हैव गिवन यू स्मॉल d, so braking torque is how much? So braking torque in this case, TV is equal to Ft into d by 2. So this is the braking torque, and this braking torque का क्या मतलब है? ये जो इसका रोटेशन मोशन है, जो टार्क इसका है रोटेट कर रहा है, तो ब्रेकिंग टार्क हुआ जो अपोजिट डायरेक्शन में एंटी क्लॉकवाइज डायरेक्शन में जो टार्क होगा, ब्रेकिंग टॉर्क एट द सेंटर, this is Ft by 2, and this is also the energy, you can say this is also the amount of energy Ft into d by 2, this is being absorbed by the brake. So this is about all the system, that different type of energy is being absorbed by the brake when we will apply the energy. So this is in detail I have given you, calculated each and everything. No doubt you will not get the problem from this side, but here I want to explain you, I want to give the complete information about this topic. So I have explained this, otherwise it is not so important, but you must know, you must have the idea of this, how the brake is being applied, what happens, where that energy goes, and how much the energy is being absorbed by the brake. So this is all about that. Now the next one is, sorry, so एनर्जी अब्जॉर्ब के ऊपर तो मैंने आई हैव गिवन यू ऑल द डिटेल ऑफ दिस. नो, जब ये एनर्जी अब्जॉर्ब होगा, व्हाट हैपन्स, दैट एनर्जी विच इज बीइंग अब्जॉर्ब्ड बाय द ब्रेक, दैट इज transformed into heat, and that heat is being dissipated to the surrounding air. So the next I will take this heat dissipated. Right. So energy absorbed energy absorbed by the brake, that implies transformation of the heat, energy absorbed by the brake, that the energy which is absorbed by the brake, that transforms into heat, and this heat, you can say this heat is dissipate to the surrounding air. तो ये जो हीट है, ये इमीडिएटली इसको हमने क्या करना है, सराउंडिंग एयर के ऊपर ये हीट को जल्दी से जल्दी डिसिपेट होना चाहिए. क्यों, किस लिए होना चाहिए? इन ऑर्डर टू अवॉइड the temperature rise of the friction lining in order to avoid the temperature rise of the friction lining of the shoe, राइट। तो इसको जो फ्रिक्शन लाइनिंग है टेम्परेचर राइज जो है इतना ज़्यादा नहीं करे कि जल्दी से जल्दी इसको हम डेसिपेट करेंगे सराउंडिंग एयर में, कि अगर इसका टेम्परेचर राइज होगा फ्रिक्शन लाइनिंग का, सो दैट विल हार्म द फ्रिक्शन लाइनिंग और द फ्रिक्शन लाइनिंग विल वार्न आउट एंड देन द कैपेसिटी ऑफ द ब्रेक विल डिक्रीज, राइट। सो एक्चुअली दिस इज द प्रोसीजर। मीन्स पहला क्या था, ब्रेक लगाएंगे, एनर्जी ऑब्जॉर्ब होगी, एनर्जी जो ऑब्जॉर्ब होगी वो हीट में ट्रांसफर होगी, और जो हीट में ट्रांसफर होगी एनर्जी उसको डेसिपेट करेंगे सराउंडिंग एयर में। रीजन मीन्स व्हाट, द टेम्परेचर राइज ऑफ द फ्रिक्शन लाइनिंग ऑफ द शू, राइट। सो अब तक इनका डिफरेंट वैल्यूज, मटेरियल की, फ्रिक्शन लाइनिंग के मटेरियल की डिफरेंट वैल्यूज जो हैं वो मैं आपको बताऊंगा। तो इसमें एक हाईएस्ट परमिसिबल टेम्परेचर फॉर द फ्रिक्शन लाइनिंग। तो अगर डिफरेंट टाइप की आपकी फ्रिक्शन लाइनिंग होंगी तो उसका जो टेम्परेचर होगा वो कितना विथस्टैंड कर सकती हैं, कितने टेम्परेचर तक आपको उनको टेम्परेचर आपका राइज होना चाहिए और कहाँ तक वो प्रॉपरली विथस्टैंड कर सकती हैं, कि अगर उसके ऊपर टेम्परेचर आपका इंक्रीज होता है तो देयर इज ए डैमेज वार्न आउट ऑफ द फ्रिक्शन लाइनिंग। सो फर्स्ट आई विल से, अगर आपका लेदर है, फाइबर मटेरियल है, वुड फेसिंग है, तो अगर जे वाला आपका मटेरियल है, सपोज करो आपकी फ्रिक्शन लाइनिंग जो है लेदर की है, फाइबर है, वुड फेसिंग है, तो ये मैक्सिमम कितना टेम्परेचर विथस्टैंड करेंगी, कितना टेम्परेचर ये बियर कर सकती हैं। सो बियरेबल टेम्परेचर जो इनका होगा, यू कैन से दिस इज 65 डिग्री टू 90 डिग्री तक, राइट। सो इन दिस केस दिस विल विथस्टैंड टेम्परेचर 65 डिग्री टू 90 डिग्री। सो सेकंड केस है एवेस्टस है आपका, और मेटल सरफेस विद वेस्टस है, मेटल सरफेस है, तो उस केस में आपका क्या होगा, स्लाइटली विथ स्लाइटली लुब्रिकेटेड है आपका। सो विथ स्लाइटली लुब्रिकेटेड। सो इस केस में आपका टेम्परेचर होगा 90 डिग्री टू 145 डिग्री। सो वी विल टेक द टेम्परेचर 90 डिग्री टू 145 डिग्री। इस केस में आपका टेम्परेचर यू विल टेक दिस मच, ठीक है। सो दिस मच ऑफ टेम्परेचर दिस विल विथस्टैंड। और तीसरा आ जाता है आपका ये जो ऑटोमोबाइल्स है हमारा, इन ऑटोमोबाइल्स Vastus with Vastus है with block lining है, Vastus with block lining। तो इस केस में this will withstand the temperature up to 180 degree to 225 degree centigrade. So this is the highest permissible temperature for the friction lining material, right? कि जब कितना हाईएस्ट परमिसिबल टेम्परेचर जो ये विथस्टैंड कर सकती हैं, इफ इट इज मेड ऑफ लेदर है, फाइबर, वुड फेसिंग है, इन दिस केस इट विल विथस्टैंड द टेम्परेचर बिटवीन 65 डिग्री टू 90 डिग्री। एंड इफ द सेकंड केस, इफ आई विल टेक से वेस्टस आर मेटल सरफेस विद स्लाइटली लुब्रिकेटेड, राइट, स्लाइटली लुब्रिकेटेड है, कंप्लीट लुब्रिकेशन नहीं है, स्लाइट लुब्रिकेशन है। So in this case that will withstand the temperature 90 degree to 145 degree. And in automobile where the vestus with block lining is there, in this, and this is a completely lubricated, this I have not written here, but this is completely lubricated, full lubrication you can say, in this case full lubrication, and this will withstand the temperature 180 degree to 225 degree centigrade. So this is about the friction lining material, highest permissible temperature which it will withstand. This is I have given the आपको different material का different temperatures आपको दिया है. So this is about, now the next one is so next one is heat absorbed, or you can say heat generated. पहला था हीट डेसिपेशन के ऊपर पड़ा, अब हीट जनरेशन। सो ये हीट ब्रेक हीट कितना जनरेटर करेगा, जितना ये हीट एब्जॉर्ब करेगा। सो हीट एब्जॉर्ब this is equal to the heat generated, energy absorbed, heat generated, right? So here you can say normal pressure P between the contact surfaces of between the contact stresses. So this depends upon the normal pressure between the contact surfaces. So this depends upon also Hg, you can say Hg depends upon the normal pressure, right? So this is very important parameter, pressure, normal pressure. This is very important parameter to design the equation of the brake actually. So this is very important one. So here you will say that the heat generated, this is normal pressure is the important parameter, and this depends upon the normal pressure between the contact surfaces, and the normal pressure So this normal pressure between the contact surfaces. So normal pressure, what normal pressure? So normal pressure, अब नॉर्मल प्रेशर किस पे डिपेंड करेगा? नॉर्मल प्रेशर्स डिपेंड्स अपॉन फर्स्ट मटेरियल ऑफ द ब्रेक लाइनिंग. फर्स्ट ये करेगा मटेरियल, ब्रेक लाइनिंग का मटेरियल कहना होना चाहिए मटेरियल ऑफ द ब्रेक लाइनिंग. सेकंड coefficient of friction, and the third one is rate of energy absorbed. Rate of energy absorbed by the brake. तो क्या है ये हीट जनरेटेड और हीट एब्जॉर्ब. यू कैन से दिस डिपेंड्स अपॉन द नॉर्मल प्रेशर बिटवीन द ब्रेकिंग सरफेस और contact surface at some particular speed, at some particular speed, and this you can say pressure. This also depends upon the material of the brake lining. brake lining का material कैसा होना चाहिए, coefficient friction के ऊपर, और rate of energy absorbed by the brake, right? तो pressure भी इसके ऊपर depend करता है. So you can say तो energy absorbed is how much? Energy absorbed this is equal to Hg this is mu into Rn into V. So energy is absorbed, this is equal to mu into Rn into V, where Rn is the normal force which is acting perpendicular to the contact surface. V is the peripheral velocity. V क्या है आपका? V is the peripheral velocity of the drum, and this can also be written as in term of pressure, because if I said you that pressure is the most important factor here in case of heat generated, right? This is very important factor, and this is also very important factor to design the equation of the brake. So Hg you can write down like this. Hg, this is equal to mu into P into A into V. So this is very important relation, and you will get the numerical, you will get the problem from that's calculate the heat generation, calculate the heat dissipation. So these are the formula also. So this relation you have to remember, and you will get the problem on this. You may get the problem on this. So this is your this, or and what is your this? Here is your the P is the pressure between the braking surface. म्यू तो आपको पता है कोफिशिएंट फ्रिक्शन है. एरिया ए इज द प्रोजेक्टेड एरिया ऑफ ब्रेकिंग surface, and V, which I have already given you, this is the peripheral velocity of the drum. So this equation Hg is equal to mu into P into A into V. This is the equation of the heat generation. So now I will give you a formula of this heat dissipation also. That heat dissipation is how much? This is heat generation, and so heat dissipated, heat dissipated may be given by, this is Hd, this is equal to C into T1 minus T2 into AR. Right. This is very important relation. This one very important, heat generated, you have to, there are the numericals problems you will get in your university examinations. Hg is equal to this one, and heat dissipated may be given by this C is equal to T1 minus T2 into AR, where C is what? Where C is dissipation factor, where C is heat dissipation or coefficient of heat transfer. Its value you remember. So C का जो value है, you remember it, 29.5 degree. W upon meter cube upon degree centigrade, when the difference in temperature T1 minus T2 is 40 degree or less than this, right? And the value of C is 44 W m cube into degree 60, when T1 minus T2 up to 200 degree centigrade. So this is the value of heat dissipation factor. And what is AR? AR is what? AR is projected. AR is projected area of the radiating surface. AR is projected area of radiating surface, and T1 minus T2, this is T1 minus T2, this is your temperature. This is your temperature difference. Temperature difference between radiating surface and the surrounding. So this is about your this heat dissipated may be given by HD is equal to C into T1 minus T2 into AR, and this is the description of this. This is very important one, and you must remember also. Now, one more relation which I want to give you. So that relation is so if we will calculate the exact performance of the brake, you can say exact performance of the brake. So how we will calculate the exact performance of the brake? This one. Exact performance, so much. So when the heat is absorbed by the brake, right? When the energy is absorbed by the brake, what happens? That energy transfers into heat. So that energy transfers into heat. You can say that 25% of the energy, 25% of the heat is immediately dissipated to the surrounding 25% हीट जो है इमीडिएटली डेसिपेटेड टू द सराउंडिंग एयर। तो 25% हीट तो एकदम इमीडिएटली डिसिपेट हो जाएगी सराउंडिंग एयर में। अब रिमेनिंग जो आपका 75% है, रिमेनिंग 75% जो आपकी हीट है, रिमेनिंग 75% जो आपकी हीट है, ये कहाँ जाएगी? दैट इज बीइंग एब्जॉर्ब्ड बाय द रोटेटिंग ड्रम, राइट? दैट इज being absorbed by the rotating drum and to increase its temperature। तो इसका टेम्परेचर को क्या करेगी? ये इंक्रीज करेगी। So here HE कितना आएगा इसमें? Not HG, but here we have to calculate the increase in temperature. So delta T, this is equal to HE divided by M into C. This is the rise in temperature in the rotating drum. This is the rise in temperature in the rotating drum. Delta T is equal to Hg upon M into C, where Hg is the energy absorbed, M is the mass of the drum, and C is the specific heat. C क्या है आपका? Specific heat of the material of the drum. C is the specific heat of the material of the drum. One more point actually which I want to explain here. So this point is, here the rise in temperature, you can say, or the increase in temperature, precisely it is very difficult to calculate the increase in temperature here, right? So in this case, to calculate in the preliminary design applications, what we will do, because it is very difficult to calculate this temperature, so you can say increase in temperature, you can say in preliminary design, increase in temperature, we will take the value of P into V, where P is the pressure and V is the peripheral velocity, right? So its value is given, its permissible value is given in the table, and you can calculate this value PV from the table. Instead of this, if you cannot calculate that difference in temperature, it is difficult to get it. So the value of PV, this is in the table, you can say when the load is continuous one and poor quality of dissipation of heat. In this case, अगर आपका continuous load है, मैं PV का थोड़ा आपको वैल्यू दे देता हूं. The value of PV, आप कह सकते हैं, if the load is continuous, in the lowering operation and poor dissipation of heat. तो इस केस में जो आपका वैल्यू PV का जो वैल्यू है, ये खैर आपके पास टेबल भी होगा, जस्ट आई एम जस्ट गिविंग यू द आइडिया. सो PV का वैल्यू आई थिंक 0.98 into 10 raised to power 6. So this is the value of PV if the load is continuous one, lowering operation, poor dissipation of heat है. तो दूसरे में अगर आपका इंटरमिटेंट लोड है, उस केस में आपका वैल्यू होगा 1.93 सेकंड है. अगर आपका लोड इज इंटरमिटेंट, इफ द लोड इज intermittent and complete rest है बीच में, again poor dissipation of heat है, poor dissipation of heat. तो इस केस में भी जो वैल्यू होगा इसका 1.93 इंटू दिस. सो थर्ड कंडीशन में लोड आपका कंटिन्यूस है एंड गुड डेसिपेशन ऑफ हीट है. लोड आपका क्या है? कंटिन्यूस है, लोड कंटिन्यूस एंड गुड डेसिपेशन ऑफ हीट and good dissipation of heat. तो इस केस में आई थिंक 2.09, just check it from your table and book. I am just giving you the idea that the value of PV, if the condition of load is like this is the value of PV is given. If the load is intermittent one and the poor dissipation of heat, then it is 1.93 into 10 to 6, and the continuous load or good dissipation of heat, the heat value of this. So this is all about your, you can say, the brief description, theoretical portion of the brake. Now tomorrow I will take the next class of your this types of brake and their equation of braking torque and the load applied, right? So this is actually this, I want to give you the each and every detail of the chapter. So I have started from here, otherwise directly I will go to the types of the brakes and then derive the equations and then go for the numericals. But mostly the people, they don't teach this one. They just simply give the derivation, a definition of the brake, and then they go on the types of brake. But I want to give you the full explanation of this chapter. I think that you have liked it too much. Each and every point I try to explain it, and today this is all about that. I think everybody has understood it well, and you tomorrow again I will take the next lecture, which is the type of brake. Now thank you. Good evening to all. Thank you very much.